But in example 1a, we're back to degrees again, and the domain is negative 360 to 0. Okay? Now, the equation itself, 7 plus 2 sine x equals 4 sine x plus 5, initially looks complicated, but this is the same as a question you would have had in grade 11. You want to solve for sine. If you want to solve for sine, you need to get sine by itself. Can you see that I could move the 5 over to this side and get 2, and move the 2 sine x over to this side, and divide both sides by 2 and get sine x equals 1. So pi plate, when is sine x equal to 1? Okay, we're in degrees though. Okay, but this might happen. You might do that. You might write pi over 2. And then you go back and read the question again, and the important thing is to look at the domain. Okay, we read that again, and then we also notice that it says, then write the general solution. So we got pi over 2, but the domain is in degrees. So then you might be thinking, well, that's actually 90 degrees. But that still doesn't fit in our domain, because our domain says we need to go once around the circle in the negative direction. 90 degrees on our unit circle is up here. But if we're going in the negative direction, what is the actual angle? Put lines through those. Negative 270 degrees. And in this case, would you agree that in one full time around there's only one solution? That 90 degrees or negative 270 degrees is the only solution. When we go to write our general solution, if we think, what did our notes say for the general solution? First, solve between 0 and 2 pi. But now we're in degrees, so that would be first solve between 0 and 360 degrees. What did we get our answer to be? 90 degrees. And then we added 2k pi, but we can't do that this time because we're in degrees. We're going to add k times 360 degrees, where k is an integer. So let's say you did this on a homework assignment, and then you checked the answer key, and the textbook's answer key had this. What did you do wrong? That's a mean question, because you didn't do anything wrong. Your answer is completely right. So then you could say, well, what did the textbook do wrong? Which isn't as mean, because I don't know how many feelings textbooks have. But the textbook didn't do anything wrong either. Does it make sense that both of those answers are right? Because you just need to start with a solution that's right, and then every time you add or subtract 360, you'll get all the other ones. And since 90 and negative 270 are the same coterminal angle, they include each other in their answers. Me, personally, I like the one where you take the first positive ones, or all the positive ones from 0 to 2 pi or 0 to 360, and use those ones. But I think some of the textbook answers have whatever answer you got in A, they use that in the general solution. No, because we've talked about that before. Like in the general solution, sometimes we have the solution more than once. Okay. I mean, it's nicer if you know it's only one. If you started writing 15 solutions that were all the same, then I'd be like, come on. Part B. Use algebra to determine the general solution of the equation cos 3x equals -1 over the set of real numbers between -2 pi and 0. Now, since this question asked for the general solution first, since it asked for the general solution first and then list the answers in the domain, are you all right if we use method 2 for the general solution? So method 2 for the general solution is first we write the general solution for 3x. When is cos x equal to -1? From 0 to 2 pi? Just at pi. That's the only place. So there is our general solution for 3x. Then our general solution for x divide everything by, by 3. Divide everything by 3. And you have your general solution for x. It then says, then list the roots in the domain from -2 pi to 0. So for this, we could use our solution in A, or what we've done already to figure that out. Or we could use method 1 that we did before. So I'm going to show you how you could use both. Okay? If you have this as your answer, and you want it in this domain, can you see that that's once around in the negative direction? Okay? So if k is 0, the answer is pi over 3. That's not in our solution. The first solution would be when k is -1. So I'm going to just write here. If k equals -1, you would have pi over 3 minus 2 pi over 3. Already got a common denominator. There's one solution. Try to determine if there are more solutions. Well, the next value that k could be is -2. Then you'd have pi over 3 minus 4 pi over 3. And that would give me -3 pi over 3. Is that still between 0 and -2? Wow, that doesn't look like pi at all. There we go. Make it fancy. Is that still in our domain? Okay, then you do another one. If k is equal to 3, or sorry, -3, then you would get pi over 3 minus 6 pi over 3. Is that still between 0 and -2 pi? And if k is equal to -4, pi over 3 minus 8 pi over 3, -7 pi over 3, and that one's too far. So these are our only 3 answers. So you can use your general solution to find actual solutions just by plugging in values of k that fit the domain that you're given. If you wanted to solve if you wanted to solve between 0 and negative 2 pi using the first method that we looked at, the first method says, well, if my original domain is between, it would be on this side, negative 2 pi and 0, if that's my original domain for x, then 3x's would be between negative 6 pi and 0. And then we could go and solve, what was the original question again? Cos 3x equals 1. Well, we know where does cos equal 1 at pi, but pi isn't between negative 6 pi and 0. We would have a negative pi. That would be the first time around in the negative direction. And we need to go 3 times around in the negative direction to get to negative 6 pi. So first time around negative pi, second time around negative 3 pi, third time around negative 5 pi. And then to solve for x, divide each of them by 3. And can you see we got the same answers as we did from before? Oh, that's a good question, because I wrote it down wrong. But negative 1 would be at pi, so we solved it right even though we just forgot that negative. So they're both helpful, right? Maybe you like method 1 for actually solving in a domain because you can just multiply and then figure out your answers in that domain. Maybe it's a little bit easier, but it's neat to see how you could use the general solution to figure things out as well. Okay, so try questions 4, 8, and 9.